So, good morning. So I get the privilege this morning of introducing Sindhu Madhavan. She's the studio lead and head of R&D for Michael Green Architecture. With over 13 years' experience in the design and delivering of innovation, high-performance projects, and demonstrated history of developing strategic research and knowledge-sharing initiatives in architecture. Sindhu's passion for meaningful sustainability has led her to pursue academic and professional opportunities in Toronto, Vancouver, having a broad range of typologies, or experience in a broad range of typologies, including academic, residential, and office projects in Canada and the U.S. Sindhu has a commitment to successful project delivery through innovation, material choices, collaboration, design process, and thoughtful management strategy. And we're lucky to have her because she speaks both here as well as abroad on all these topics. So with that, we'll hand it over to Sindhu.
Thanks for that really wonderful introduction, and sorry if I stressed you out with my laptop a little bit there. It can get a little chaotic. Hi everyone, my name is Sindhu Mahadevan. I'm an architect, and as I was introduced, I'm an architect and studio lead and head of R&D at MGA. And I'm here today to share our experience with LCA across different types of projects and some key trends we have observed and lessons learned that can inform future work. So I'll start off today with a brief introduction of who we are as a firm and what we do, and then I'll dive right into why LCA is important and how it can really set up a project for success. And then we'll get into case studies, and this is where we'll spend most of our time today. We have three types of projects in our case studies: an office building, a community center, and an institutional building, all of which had undertaken LCA through different methodologies and different approaches. So it'd be really interesting to compare and learn from the different lessons that we have learned from each of them. And then lastly, and then fourth, I'll share some consolidated thoughts on how these LCAs we have undertaken continue to inform and improve our design process. And then lastly, some thoughts on where we see all of this going. So as an architecture, interior, and research practice, MGA, Michael Green Architecture, is driven by two core missions. The first is, how can we support people through our work? That is by designing healthier and resilient communities, safer and welcoming neighborhoods, and warmer and inviting homes, and really finding opportunities to improve our mental health and well-being through good design. And second is, how can we reduce our impact on the planet? That is by designing buildings that touch the earth lightly, that use less materials, and use healthy and low-carbon materials, and really finding opportunities to make our planet healthy through good design. And this is why our firm embraces a twofold approach of use less and use wood where possible. Use less because we all intuitively understand the value of having a lighter and gentler touch on the planet. Use wood where feasible because of a handful of reasons. It is the only material that's grown by the sun, it's renewable, it can be reused if designed appropriately, and it sequesters carbon, and it has a relatively low carbon footprint to even fabricate. And these are some of the folks that I work with who deliver on these core values. We're a team of about 40 people with two principals, Michael Green and Natalie Televiak, and we are located in 3 offices, one in Vancouver, one in Victoria, BC, and more recently, one in Europe. And I'm really happy to say that we all share a collective passion for the environment and the outdoors, and we're really motivated to do work that can benefit both people and the planet. And before we dive into the case studies, I'll set the ground on why we feel so motivated to pursue architecture that is sustainable and low carbon, and how that's connected to LCA, which is the main topic of discussion today. And so to answer this, I think we have to dial back in time to about 200 years or 201 years, when the concept of greenhouse gas, that is, gases that trap heat inside the planet's atmosphere, was introduced by scientists in 1824. So what this tells us is that this concept is not only centuries old, our collective scientific understanding of our impact on the planet has grown a lot since, particularly on the building sector, which is responsible for about 42% of greenhouse gas emissions around the world. And this will continue to grow as we need to build more. And this number is driven by 2 types of emissions, embodied and operational carbon. And I think most folks here might be familiar with the concept of embodied and operational carbon, so I'll just do a very brief refresher and we can get right into the case studies. Embodied carbon is the emissions that result from the extracting, processing, fabricating, and assembling of buildings. And this is just over a third of the 42% that I mentioned earlier. Operational carbon is the emissions that result from the day-to-day operations of the building, that is to keep the lights on, to keep the building systems running, to keep the heat on, et cetera. And this is the remaining about 2/3 of the 42% that I mentioned earlier. Now, this ratio can vary depending on where you're located, depending on what your energy grid is, and depending on a number of other factors. But generally, this ratio of embodied to operational is more of a global trend that we're seeing. And what's important to remember here, though, is that all of the embodied carbon of a building is emitted by day one. And that's because all of the emissions associated with extracting, processing, and fabricating the materials that go into your building are already emitted before the building opens. So what this means for our industry is that the only opportunity to change the embodied emissions for our building is before and during design. And this is why we believe that architects and early decision makers need to take this seriously and urgently. We have the agency to make an impact and reduce our industry's footprint, and this shift requires big ideas. And big ideas need collaboration and buy-in from early adopters and innovators who can realize an idea and see it through. And we do this work through our practice by reducing our industry's footprint. We do our part by designing buildings that have a much lower carbon footprint. And we're able to do so because of all the incredible clients and policymakers and government officials and contractors and engineers and developers and stakeholders who are all willing to take the steps to see this through with us. And the end result are these beautiful wood buildings that we all enjoy and experience, and more importantly, hopefully will endure over time. And because we also love data, and I'm a big data nerd, we also like to assess how we're doing. That is, how do we quantify our impact? How do we improve? What are the metrics? And this is where embodied carbon and LCA comes into play. And I'm excited that this question of embodied carbon and LCA has really picked up momentum at a municipal, provincial, and federal level, from the City of Vancouver's embodied carbon guidelines all the way to NRC's National Whole Building Life Cycle Practitioner's Guide. And the fact that there's now a shared body of knowledge that we can all build upon and support broader reporting and hopefully learn from each other is a very important, meaningful step, I think, to shifting our industry to a low-carbon future. So now that we've established why LCA is important, let's look at how this unfolds into 3 parts. At the beginning of a project when we're setting it up, through case studies of 3 projects that I'll walk us through, where we've completed LCAs and what lessons we've learned from them, and then looking at ways to shift our thinking before and during design for better outcomes for future work. So looking at project beginnings, we know that so many aspects of our building are decided during design and long before a shovel hits the ground. And within that design process, so many aspects of the project are also locked in pretty early. That is, where we're building, where the site is, what the key parameters are for program and function, what structure will be in place sometimes, and how we evaluate all of this, budget, schedule, etc. So one strategy is to get alignment in all the goals here collectively with the owner, municipalities, design team, and stakeholders on what are we trying to achieve, how will we make decisions around material choices, around carbon, and so when the project does progress and there are budget questions or tricky decisions to be made, this is the baseline we always come back to. And we usually document this in a project charter or a summary that we can always come back to as a reference point. And specifically on setting up an LCA for a project, we like to look into, firstly, what is the purpose of the LCA? That is, what is it used for? Is it an education tool? Is it a post-design awareness effort? Is it an iterative tool during design? Are you using it for LEED or other certification or regulatory compliance? And these are important questions to ask early, because often the tools and methodology that you will end up with is often narrowed down by this step, especially if it's related to a regulatory or a compliance effort. And this brings us to the next item, which is what tools will we be using for LCA and what's the workflow? There are a number of tools out there, from Athena to OneClick to Tally and so on. So, and the case studies I'll share today, all of them actually use different tools, which is really interesting, and we'll talk through what that means for the outcome and the results. So using the right tool that aligns with the project workflow is super important so that the LCA becomes part of the design process and not an obstacle and not kind of an additional effort that gets tacked on, which means often it also comes off. And lastly, the LCA methodology itself. That is, what are we including in the LCA? What are we counting? What are we excluding? What system boundaries are we putting in place? And what baseline assumptions are being made? Looking a bit closely into the LCA methodology, in our experience, based on several LCAs that we have undertaken or collaborated with on our projects, there are two key aspects to an LCA methodology. One is the objective assessment. That is, what materials or products or assemblies are we assessing? What's included, that is it the structure, envelope, finish, et cetera, and what's in and what's out. And then there's system boundaries, that is how far down the line do you go for a given material? Is it just the extraction and processing? Does it include transportation, repair, demolition, reuse, et cetera? And we'll touch on this further in the case studies, and you'll see that each case study has a slightly different approach for a number of reasons, which then creates quite a bit of variation in the results. So, as I said, looking at the object of assessment, looking at what's in and out, typically what you're seeing on the left are the things that are typically included, which is structure, superstructure, that is your foundation and your structure above grade, substructure, and your superstructure, that's your foundation and your structure above grade, and then your enclosure, that's your exterior building envelope, and stairs, so most core and shell elements. What's excluded, and as you can already see, the list that's out is quite extensive, are things like MEP, that's your mechanical, electrical, plumbing, fixtures, your finishes often, conveying systems like elevators and escalators, furniture, site and surface parking, site infrastructure, and temporary works, that is means and methods that are used to construct a building. Interior partitions is sometimes in, sometimes out, depending on the methodology and the tool and the process that you're using. So this is worth keeping in the back of our minds as we study LCA, as you do come across LCAs for different projects and as you study them, to keep in mind what's included and what's excluded. And looking at system boundaries, the diagram here describes the life of a material from extraction to end of life. So starting from the left, the extraction, what you're seeing is the extraction and transport to manufacturing facility and the manufacturing of the material itself. And this is typically included in the EPD, or the Environmental Product Declaration of the product or material itself. And then what's on the right is how the material gets to site and how it's serviced, what its repair needs are, and its end of life. And this is typically calculated by the LCA software that you're using, and it's based on your project-specific parameters. And related to this is also the industry-wide stages for a whole life carbon for a building, and how embodied, and I'll just walk through how embodied carbon fits into that. So on the left side is A1 to A5, which is the upfront carbon, which we just talked about, which is related to the raw material supply all the way to installing it in your building. And then in the middle is B1 to 7, which is the use and repair during the life of a building. And another aspect of the use stage of the building is operational carbon, which you may recall is a significant portion of a building's total emission. And this can be calculated separately and sometimes reported depending on your methodology and system boundaries. And on the right side is the end-of-life stage of the materials and products, that is disassembly, disposal, and waste. And most LCA tools that are available in the industry have some kind of description of what their system boundaries are. If you look through the notes and methodology, they do disclose what their system boundaries are, and they do describe this quite clearly. And because the projects we will be talking about today are heavily bio-based and use mass timber or timber hybrid, one aspect to be aware of is how biogenic carbon is calculated. Biogenic carbon refers to carbon that originates from biological sources, such as plants and animals. It's the carbon that's absorbed from the atmosphere by living organisms and trees, and it's sequestered or stored within the organism itself. So when we place timber in our buildings, be that CLT, glulam, or any timber product, we're also storing or sequestering the carbon that's already in the timber in our buildings, hence the term carbon sequestration. Now, this is reported in different ways, in different LCA methodologies and LCA tools, and there's a lot of debate in the industry. So in our experience, when you factor in biogenic carbon, it could make anywhere up to maybe even 40% of an impact difference when you include it or you don't. But this is something to be aware of, and typically we do report on this separately. And looking at this globally, here's a snapshot of how much variation there is in LCA methodologies, specifically in system boundaries around the world. As you can see, it's a little tiny on the screen, but as you can see, there's so much variation in terms of what's in and what's out and what's optional across different countries and across different tools. So it's important to keep this in the back of our minds when we're comparing two different LCAs. So now that we've wrapped our head around, hopefully, around what LCAs are and why they're important and all the complex parameters and criteria that go into making an LCA, we'll get into our 3 case studies. The first case study I'll walk us through is WIDIC, the Wood Innovation Design Center, which is an office building located in Prince George, BC. And the second case study I'll walk us through is the Quilchena Community Center, which is a community center that's located also in interior BC on the lands of the Upper Nicola Band. And the third case study I'll walk through is an institutional building, or cultural building, I should say, which is the Royal BC Museum's Archives, Research and Collections building located on Vancouver Island. WIDIC is completed, and the other 2 projects are nearing completion in a span of a few months or so. And all 3 are located in BC. And all 3 have different drivers for LCA, as you can see. For WIDIC, the driver was actually twofold. There was the 2 LCAs that was done for WIDIC, which I'll get into momentarily, one for a certification compliance and one as kind of a post-project understanding. And then for Quilchena, it was more of a certification compliance for a zero carbon building. And then for the museum project, it was more of an iterative process based on a number target that was established at the beginning by the client. So starting with our first case study, the Wood Innovation Design Center, which is about a 4,785 square meter project, or about 50,000 square feet office building located in Prince George, BC. This is very much a first of its kind in North America. At the time of its completion, even though it doesn't look very tall now, it was the tallest wood building at the time of its completion. It was just under 30 meters. And it was a very, very fast design-build process. From start to finish, it was about 18 months. And it was a very concerted effort by various levels of government and stakeholders, including Partnerships BC, the City of Prince George, the forestry industry, and the design and construction industry. And recognizing that at the time when this project was conceived, and as you can see, the building was completed in 2014, so that was about 11 years ago. So at the time when the project was conceived, which was a few years before that, the building codes had not quite caught up yet. So there was a site-specific regulation that was written to specifically allow for this project to be built. And one of the key project goals and objectives for WIDIC is to showcase an innovative use of next-generation wood products and technologies, and really highlight wood expertise and leadership, and develop commercialization capacity for large buildings using wood products. And another focus was also on strengthening the local forestry economy in light of global factors at that time, including pine beetle impact, for instance. So it wasn't necessarily entirely on carbon, but carbon was a very, very important aspect of it. The massing approach, as you can see, it's very, very simple. The building, in terms of materials, the building was essentially set out on a raft slab, a concrete raft slab, and above that there's no concrete beyond the slab on grade. So acoustics and fire separation were all achieved through dry systems, which is something that we still don't see repeated a lot today, but it was a really innovative and interesting thing to test out on this. The building grid is quite simple. It's a simple 20 feet by 20 feet grid on post and beam, and it's about 6 stories high with a mezzanine on the first level. The building envelope is a prefab envelope with zip walls that's structurally insulated panels with wood cladding and double-glazed curtain walls with timber-backed mullions. And so as you can see in the images here, I'll just point. So as you can see in the images here, the structure was essentially a CLT core, CLT floors, and CLT roof with glulam post and beam. And programmatically, the building provided office space for different provincial offices and industry use, as well as academic and research space for the University of Northern British Columbia. And here's a closer snapshot of the dry system that I mentioned earlier that's typical to every floor above the slab-on grade. The floor assembly is essentially a corrugated floor system, so it's a 3-ply, 5-ply CLT, and a 3-ply and a 5-ply CLT, which creates chases at the top and the bottom to conceal surfaces. And then we ran acoustic mats and plywood panels to conceal the floor chases and wood slats to conceal the ceiling chases. And a significant amount of this structure was intended to be exposed as finish in the spirit of using less. And there was also a number of engineering judgments for the floor assemblies that we won't get into today. And as I said, the project was only 30 meters, but it was intended to be repeatable, and it was intended to be so simple that it can be repeatable. And I think there's a lot of taller wood buildings now, which we're really happy to see, which is really built up on this idea of building tall wood buildings. So getting into the LCA for WITIC. As I mentioned earlier, there were two types of LCA that were done for WITIC. In the early days when LCA were not as prevalent, which we'll also get into a little bit. And so what you're seeing here are images as we go inside the building, which is interior fit-out elements in the wood shop, for example, the equipment in there and the millwork, or the wood slat finishes that you're seeing in the lecture theater, or the furniture in the office spaces that you're seeing there. Those were not included in the LCA. As you can see, a lot of the wood finish was also intended to be exposed, and so the structure was included. So these are the two types of LCA that were undertaken. The first one, the one at the top, is the LCA that was undertaken towards the end of design by FB Innovations, and this was a comparative LCA to a baseline with the intent of supporting the LEED credit to achieve a 10% reduction to a concrete baseline. And so the systems boundary and the objects of assessment were defined by LEED with the assumptions that associated with that. After construction, or towards the end of construction, another LCA was done by Athena, which provided more transparency on building performance, and what they created was essentially an EBD, which is an environmental building declaration, similar to an EPD, which is an environmental product declaration. I realize it's a bit of an acronym soup. And the EBD is for an entire building. And it's more common in Europe than in North America, but and so there is a standard in Europe, the EN 15978, don't quote me on that, but there is a European standard specifically for EBDs that was adapted for this project. And it's a bit more comprehensive than the LCA that was undertaken during design for LEED compliance. And right off the bat, you can see this is a high-level summary of the differences between the two LCAs that were undertaken. And right off the bat, you can see what's included and what's excluded between these two, the LCA that was undertaken for LEED and the LCA that was undertaken for the Environmental Building Declaration. So this creates two different results, essentially. And this is just the system, this is just the difference in system boundaries. In addition to these different assumptions for these two LCAs and system boundaries, there were also differences in assumptions and level of detail, which can make a huge difference. So, when you're comparing LCAs, sometimes, even if it's for the same building, it feels like you're comparing apples and oranges. So it's helpful to compare. Often one approach around this is it's helpful to compare an LCA to a baseline that you create yourself, so that at least the baseline assumptions of what's included, what's excluded, what your assumptions are consistent across what you're comparing. And this is why benchmarking data is always helpful, and it's something that we're seeing more and more in the industry, which we're really excited about. At a high level, I can say that there's somewhere between an order of magnitude of maybe 3x between the two, depending on how you're looking at it, which makes it really tricky to compare, even though it's the same building. And to ground this, though, if we look at the embodied carbon component, which is, if we look at just the embodied carbon component, what we do know, however, is that compared to a baseline structure, which was the LEED approach, there is potentially up to an 88% reduction of carbon in the building, because the baseline assumed a concrete structure with light gauge steel envelope, compared to a final design, which was a timber structure with a timber core and a SIPS envelope. Now, that's a helpful comparison at a high level. And again, data's not perfect, but this kind of approach helps us to understand at a high level what are the big picture items that we can, what are the big picture material considerations that we can make to make better choices for future projects. So some of the lessons learned from the LCA for WIDIC, the two LCAs for WIDIC, is that primarily, as I said, this is a bio-based structure, and including the building core and no concrete topping. So that made a huge difference in terms of comparing it to a baseline. So now today, if you do compare a building to a baseline, you may not get that 88. You're probably going to land somewhere maybe 30 or 40%. But that's, when you factor in things like what your building core is, how much concrete topping, it all just does add up. And looking at building floor area to skin ratio. And we'll get into this in some of the later projects as well, which are all one-story building compared to this, which is a 6-story building. What that essentially means is that for a single slab on grade and single layer of foundation, you have multiple floors. So your ratio of building to floor level is quite efficient. And additionally, because the building form is so simple, your floor area to your building skin ratio is also quite efficient. And that helps you use less materials and therefore keep your embodied carbon footprint lower. And of course, using structure as interior finish also helps to reduce carbon footprint, even though keeping in mind that interior finishes is not always included in your LCA, it's still a good practice to again, use less. And some of the process lessons learned is, again, finding alignment between all the parties, including province, authorities, users, contractors, and designers on your material choices from day one. And because this project was essentially a demonstration project, and there were a lot of things that we were testing out for the first time here, this is a really, really important component. Obviously, as I said earlier, the different LCA methodologies produced results creates different results. So, be wary of comparing LCAs that sometimes might just be apples to oranges. And these two LCAs were done in the early days when EPDs, that is, environmental product declarations, were not as prevalent. So there were a lot of assumptions that went into some of the carbon footprint of the individual materials that went into the building. And so, what would be interesting is if you were to do an LCA for WIDIC today, it would be interesting to see. I'm very sure it would end up somewhere in between. Maybe it'll be a pair. I don't know. And what this also prompts us to think about is to collectively step up to support technical innovation through testing and research. The next project, I'm just going to check the time. I think I'm okay. The next project I'll talk about is a community center that's about 4 hours outside of Vancouver, and this is a really special project to us. This is a 25,000 square foot building located in the lands of the Upper Nicola Band. And the main purpose of this project was to deliver a building with a really light touch, embrace net zero principles, and is still robust, and it's part of the community for a very long time. The LCA approach for this project was done through CAGBC, so the target was about 500 kilograms CO2 equivalent per meter square, and we came out much lower at 254. And the LCA was run at the end of design using one click, compared to WIDIC, which was run through Athena. The building concept, I'll just jump through a few quick slides to explain the building concept and approach. The building, again, was intended to be warm and inviting and surrounded by lots of landscape, lots of green space, and a space on the roof for future PV array to give the community more resilience. And programmatically, the building has an inward-looking gathering space with administrative spaces on the left, anchoring the gathering and the community spaces further out. And again, because this building is single-story, with a structure that's mainly a combination of mass timber and lightwood frame, you can see that this is important to remember because you can see how this distributes across the different carbon footprint of the different building components between substructure, structure, and superstructure. We didn't factor in biogenic carbon in the LCA that was reported out here, but if we did, you can see that a big chunk of that would be offset, potentially up to 40% would be offset if we did factor in biogenic carbon. And another component of LCA is the object of assessment, as I was saying earlier, that is what components you're measuring. In this case, as you can see, the foundation and the slab on grade are quite a big component because it's a single-story building, so that has a bigger impact. And also factoring in that this is a colder climate, so there's about 6 inches of insulation below the slab, so all of that adds up. But that said, that is a good I do think that's a good trade-off to make because that helps you with your operational carbon footprint. So keeping in mind that, use less, but be smart about what you're using less so that you're not then increasing carbon footprint at the other end. And beyond materials, the project also really looked into the values of the land and cycles of nature in terms of its material palette and how it approached design. And resiliency was central to the project from day one. And this is not necessarily entirely calculated through numeric values, but it does have a huge impact on how we put our building together. So the first layer, as you can see, is human experience. The second layer is climate and environment. So not just specifically to this side, that means looking at considerations of wildfire and flood management and looking at fire-smart design principles. And there are material choices that are needed there so that the building can weather climate events. And looking at construction means and methods, not just how we're putting our building together, but who are the people who are putting our building together. And this project was intended to support the local labor market as well. And lastly, looking at the funding and approvals model, which is what are the opportunities or obstacles in policy and regulation that could impact the project from moving forward. And these are just some images of the project, looking at it from the inside and out. And inside the building, as I said, there's a lot of exposed structure. In this case, we were able to use a lot of local fiber. And there's also a lot of opportunity for daylight and views to the outside. And the primary structure, as you can see, is exposed. And I don't know if this will play. Well, maybe not. Some of the gravity and lateral system of the primary structure and the community bay is lightwood frame, which is prefabricated on site. And this is a good reminder of how we can use less fiber in the first place. So using wood is good, but using less wood is even better. And the local community, I'm happy to say that the Upper Nicola Band was quite involved in the construction side of this project too. Oops. There we go. So, lessons learned from the Quilchena Community Center. Material efficiency, that is hybrid structural systems with panelized structural walls and glulam beams paired with CLT, in this project was a good way to find efficiency and really adhere to the principle of use less and use wood. The carbon-heavy underslab insulation was needed for thermal performance, but I think there's a good trade-off to be considered there. And in terms of process lessons, again, there was a lot of value alignment early on with the client and with these stakeholders who really wanted to embrace a net zero principle, a net zero project. And keeping in mind that there are ripple effects on material choices beyond just the embodied and operational carbon. Looking at where you're getting your materials, who's putting it together, how it's all coming together, there are ripple effects on your material choices. And the site here was a bit of a remote site, so there were some infrastructure challenges that we had to overcome. But that's also a good consideration to keep in mind. And my final case study today is the Royal BC Museum's Provincial Archives Research and Collections Building. And on this project's about 164,000 square foot cultural museum building located in Colwood, BC, and it is targeted to be completed early next year. And for this project, we tracked LCA from start to finish. We landed this project through a design competition where we worked through an LCA approach, and then that set the standard for a numeric LCA target that we were held to throughout the design and construction process. And this was what you're seeing here on the screen is essentially a summary of the pilot embodied the pilot study. Which is essentially what this project is based off, which is to reduce embodied carbon, which is the first provincial project to undertake such a comprehensive approach. The building layout is pretty simple. The building is essentially sloped sides, sloped roofs on two big bars on the side, which are the collection storage, and the central area is a welcoming pavilion and research space, which you can kind of see here. And this party, as it essentially shows, the building is laid out in a loop with high bays on both sides for collections to store high-density storage of thousands, actually millions of artifacts. And CLT shear walls and glulam beams and columns that you can see in the next slide here with firewalls to separate the collections from the central area where all of the mechanical systems were located on a flat roof. And so there was a real nice synergy between the building systems approach and the structural approach and the fire and code approach, which we'll get to on a different day. But what this building to me really speaks to is a really smart use of materials, different materials, and using the right material for the right job, using concrete in the right way, using timber, and using both of these materials in the right way to really balance out and create a building that's really efficient, really simple, and functions really well. And another aspect is that this museum is essentially turned inside out, where the lab space and the processing and the research space is actually in the middle and it's on display, and you essentially walk around in a loop. So if you're in Vancouver Island sometime next year, please go check it out. And looking at the purpose of this LCA, as I mentioned earlier, this was an iterative LCA to validate design choices and track against a carbon target that was set earlier at the very beginning of the project. And so the carbon target for this project was 229 kilograms equivalent per square meter. Now compare that to the Kulchina target, which was based on LEED, which is 500 kilogram equivalent per square meter. And this project has a much higher specialized spatial needs, considering that it's a museum and it has very specific spatial needs, building systems, fire considerations, et cetera. And for this project, we used Tally, and it was modeled in Revit, and Tally was used as a plugin in Revit directly to do the LCA. So another aspect is that only modeled design elements were counted, compared to other LCAs where you could potentially get a takeoff of bill of materials from your contractor, which could be more reflective of the actual amount of material that they bought to do the project. And we did LCA from early days, starting in concept all the way through schematic, and then now we're doing LCA during construction to see how it varied from design. And this is a quick overview of kind of early design LCA to detailed design to LCA during construction. So as I said, in the early design LCA, we developed the carbon target. And also, this kind of came through the client more, where a methodology was established to do an LCA consistently throughout design and construction. And then during the design phase, and I'll get into this a little bit more in the next slide, we continued to refine the model, and which helped us to continue to refine our material choices to improve our carbon performance. And then finally, during construction, we're now using actual EPDs from the materials that are being placed in the project, and then putting that back into the LCA to see how it compares to our design LCA. So during design, there were multiple iterative design packages, and each of these packages had a carbon reporting milestone. And so I won't go through all of this in the interest of time, but I'm happy to chat about this earlier. I think I have about 10 minutes left. Right? Okay. I won't go through all of this, but I'm happy to chat about this after. I can stick around for a little bit. But as you can see at a high level, starting from design package A all the way through design package D, there's a continuous effort to refine our material choices, refine our structural material choices, or envelope material choices, finding efficiencies to reducing foundation, to tightening up footing, looking at different cladding materials, et cetera, which then led us to something that we felt more confident towards the end that would align with where we need to be. And you can see that, over the course of the different packages, there's a bit of fluctuation as we inputted programmatic changes, refinements, and various design considerations, city feedback, construction feedback, all of those have an impact. And this is where it's important to also understand that when you're doing iterative LC, it's also important to understand what kind of buffer you have. Another way to think about it is how you do costing. So when you're doing a cost estimate, you have a plus or minus, often it's plus, 20% at early stages, and then that goes down to 15, 10, and 5. Another way to think about LCAs is also that you're essentially looking at the carbon budget for your project. So looking at what is your carbon budget and understanding the variation of that. And some of the material lessons learned on the RBCM project is that because it's, again, a single story with a high volume, and there's a lot of, which is needed for a lot of the collections, that then is reflected in the profile of how much carbon is taken up, say, by the structure, by the substructure versus the superstructure. And there's still quite a significant amount of wood in this project, and it is still primarily a bio-based structural building structure in a museum quality setting. And there's a lot of structural optimization that was informed by carbon. And in terms of the process lessons learned, there was a lot of iteration through design. And the methodology in this case was defined by our contract requirements. And so it was quite tailored to this pilot project, which we'll see how that evolves over time. And during construction, which is happening right now, we're studying the actuals. And during design, it was kind of a design-based LCA, so now we're comparing it to actual product EPDs, which is quite interesting. And so far, we're actually trending quite well, which is really exciting. And pulling all of this together, I'll walk through some key impacts on our design process, what lessons we have learned from our LCA, and from these LCAs and other LCAs we've done as well. So the first, as I said many times today, is to use less, embrace simplicity. What is the least amount of materials you can use to achieve your project's vision? The second is to study the project givens. So study the site, study the approach, the massing. If there are big impacts on embodied carbon due to givens, then question the given. And a good example, as I said earlier, is the number of stories and how that impacts your carbon footprint. Another example is also looking at does your project need multiple stories of parking? And in that case, is there another way to approach parking, maybe through a site, through community, through some way of reducing that carbon? And focus on the big buckets. That is a really weird typo, sorry about that. Understanding which materials have the biggest impact and start there. And iterate and collaborate. Start your LCAs early and identify material opportunities and build a process to get collective buy-in from everyone, from your client to your contractors to your builders, from your trades. Get collective buy-in from all the folks who will ultimately touch that material and put it in your building. And take the green lights. Try to make cost-neutral spec changes wherever you can, try to reduce the amount of materials wherever you can, and build that into future projects so that you're working off of an elevated baseline in the future. And accept imperfection. I realize this can all be very overwhelming to navigate through all the variations in methodology and incomplete information and complexity, but we must not let that distract us from what we're trying to do. And we just need to accept that no data is perfect. And so we can make informed choices and iterate so you can continue to innovate on the next project. Aim high, set the target uncomfortably low, and be ambitious. You might be surprised with what you can achieve if we push ourselves every time. And these 3 case studies are really good examples of really ambitious goals that resulted in some really effective low carbon and efficient solutions. And then align and measure, of course. So align on project goals early to get that buy-in, and then measure your progress and validate your decision, always going back to those project goals. So with that in mind, here's a final slide on some thoughts on where we see all this going. So if you recall from our earlier slides of system objects of assessment, it's clear that there's so much that we're not even counting in our LCA. So the first thing that we'd like to see is to increase the pie. So increase not just your structure and envelope, but increase all of the materials beyond your core and shell. And the second is to look at the full picture, so looking at the carbon impact at the scale of the building, hopefully maybe at the site and the neighborhood. What is the entire carbon impact of this project on this land? And always push for more data, more product data, more benchmark data, more data where you can, and also push for material innovation. So looking at what new materials and assemblies can build future projects, and lean into renewable and bio-based materials. We think there's so much opportunity to innovate there. And overall, continue to strive for clarity and more information, and embrace the unknowns as you embed LCA-based thinking on your projects. And that brings us to the end of our presentation today. So thank you everyone for your time. I think we have maybe a few minutes for questions. I can also stick around if you wanted to chat. And thank you, Buildex, for putting this together. And thanks, everyone.
For the museum, did you try to do the firewalls in wood instead of concrete? Was there an attempt made to see if that could happen?
We did consider it much earlier. It was, I believe, it's a 3 or 4 hour firewall. So that would have been a very chunky piece of wood. And so we ended up doing prefabricated concrete, actually, which again, if you're looking at concrete, there's quite a footprint difference between your cast in place and prefab too. And the prefab concrete just ended up being more efficient spatially. And so we ended up landing there, but maybe for a future project, yeah.
And do you do any work around planting gardens and so forth? I know there's a lot of clients of mine that plant trees to help offset the carbon footprint. Is that a consideration for your projects where you analyze the site and say, well, we'll plant X number of trees, which at the maturity will give?
That's a really good that's a really good question. So on these case studies, I don't think we did a direct carbon offset. It has come up on some other projects, and I know there are projects that do look at that. I mean, our approach, as I said, is to just use less to begin with and not rely on carbon offsets as a way to kind of get to net zero. You know, you get to net zero by just using less. That said, the museum project does have a very extensive landscape approach, although I mean, if we were to do the math, I don't think it would be a one-to-one, but it does have a pretty extensive landscape approach.
Thank you.
Yeah.
Hi. For the LCA target for the park campus, can you just confirm, was that embodied target and operational?
It's embodied.
And then what was the lifespan of the building that used for operational?
75 years. Yeah. Okay, great. Thanks, everyone. I'll let you go.